Hi everyone, welcome back to the Data Guy, your go-to channel for mastering data engineering tools and concepts. If you are new here, I am Vishal and I create videos to help you build a strong foundation in data engineering. If you are managing big data, you know the struggle of ensuring data accuracy, consistency, and scalability. Today, we are diving into Delta Lake in Azure Databricks, a modern solution that's revolutionizing how you work with data, whether you are a data engineer, analyst, or just curious about modern data management. This video will walk you through everything you need to know about Delta Lake, its features, setup, and best practices. First thing first, what is Delta Lake? Delta Lake is an open source storage layer built on top of data lakes like Azure Data Lake that brings reliability and performance to your big data workflows. Think of it as the backbone of Lakehouse architecture. Now, its key features are ACID transactions. Delta Lake provides full support for ACID transactions, which means your data operations are reliable and consistent. Whether you are writing, updating, or deleting data, Delta ensures there is no partial or corrupted data in your lake. Second one is unified batch and streaming. Handling batch and streaming data separately can get messy. Delta Lake unifies them. You can process streaming data in real time and use the same data pipeline for batch operations. This saves time and simplifies workflows. Third one is schema enforcement and evolution. Managing data schemas can be a nightmare. Delta Lake enforces schema consistency on writes, ensuring your data structure stays clean. Plus, it supports schema evolution. So, as your data changes over time, Delta adapts it effortlessly. Fourth one is time travel. Imagine you could go back in time and access how your data looked last week or even last month. Delta makes this possible with time travel. It keeps a version history of your data, allowing you to query past states or rollback changes. It's perfect for debugging and audits. Now, why do we need it? Well, traditional data lakes often struggle with issues like data inconsistency. Multiple writes can lead to corrupt or partial data, lack of schema enforcement, messy and unstructured data often creeps in, poor performance. Querying large data sets can be painfully slow. Now, this image highlights the difference between traditional file listing and Delta Lake's optimized approach for managing files in the cloud. So, in case of traditional file listing, which is on the left side, you can see on the left side, when a query engine like Spark or Hive needs to read data from many files, for example, Parquet files, it has to list and process each file individually. This results in many operations, which is slow and can make the query engine inefficient. Delta Lake maintains a transaction log, which is like a record book listing all the files associated with the data. Instead of scanning each file individually, the query engine reads the single transaction log to know which files to process. This requires only one operation, making it faster and more efficient. Delta Lake reduces the overhead of querying multiple files, saving time and improving performance, especially in cloud environments where listing files can be expensive. Delta Lake solved this problem by adding powerful features like ACID transactions, schema enforcement, and time travel. Essentially, Delta Lake combines the best of both worlds, the scalability of Data Lake and the reliability of traditional database. So, why should you use Delta Lake in Azure Databricks? Azure Databricks provides the perfect environment for Delta Lake, offering seamless integration. Delta Lake is natively supported, making it easy to use with Apache Spark and Databricks notebooks. High performance features like Z ordering and delta cache make querying large dataset fast and efficient. Scalability, whether you are handling terabytes or petabytes of data, Azure Databricks can scale effortlessly. Unified batch and streaming. Delta Lake allows you to process both batch and streaming data in the same pipeline. Now let's dive into the practical part, setting up Delta Lake in Azure Databricks. First, so I have created a notebook here and I have attached it to my cluster. So basically, first here we will create a delta table. So here in this code, what we are doing, we have just initialized a Spark session and then we define some data and its schema. And using create data frame, we have created a data frame out of it. And after creating the data frame, we are writing this data frame in a delta format to this path. Okay, so now when we run it, so it will run and it will show us message like delta table is created. Let's see this data frame. So here you can see the data frame. It has two columns, id and name. Now, we will do some transformations here. So we will perform updates and deletes basically. So it shows how Delta Lake allows you to update or delete records seamlessly. So what is happening here? So basically, first we will understand the code. So basically, Delta table is a class. Delta table is a class provided by the Delta Lake library to interact with Delta tables. And this code, basically, this line, this creates a connection to the Delta table, which is stored at this path. You can think of it as a pointing your program to the folder where your data lives, right? Now next we will update the records. So here this condition id is equal to 1. So this is like telling the delta lake find all the rows where the id column is equal to 1, and when you find those rows, change the name column to alice updated. Here you can see set name is same, set name alice updated. Now after running this code, the name for id is equal to 1 will be updated to alice updated. Let's run this code. Next we will see how to delete the records. So here in this code, the condition id is equal to 2. It tells delta lake to find rows where the id column equals to 2 and delete that record basically. So before running this, let's see output of this. We have updated this and let's see it. Updated df is equal to, we don't need version for this option. You can see the updated df. So here we have updated the records and it is reflected here. So next we will run this code. Now let's see the data frame. Here you can see the earlier data frame, it has a record 2, and the updated data frame, it doesn't have that record. So basically, how does delta lake do this? So how does delta lake manage to update and delete records without breaking everything? Delta Lake uses a copy on write mechanism. Instead of directly editing the data files, it writes new files with the changes and maintains transaction logs. This means your data lake is always consistent, fault tolerant, and even supports time travel if you want to go back and see old versions of your data. Now we will query delta table with time travel. So basically so here this code snippet demonstrate how to read a specific version of a delta table using PySpark. So this spark.read.format delta, this tells Spark that we are working with the delta table, and this option version as of now 0. This is where the magic happens. It tells delta lake to load version 0 of the table. Now remember, delta lake keeps track of every change to your table, and version 0 is the first version, the original state of the data. With delta lake, you are not just working with data, you are working with the entire history of your data. Using version as of now, you can time travel to any point in the past and see exactly what your table looked like. So let's run this code. Here you can see the version 0 of your data frame. To get the most out of delta lake, keep these best practices in mind. Use Z ordering and delta caching to optimize the performance. Regularly compact small files with the optimize command. Partition your delta tables for efficient querying of large data sets. So, real world use cases are building data warehouses for analytics and reporting, real time data processing for fraud detection or recommendation systems, ETL pipelines that unify batch and streaming workloads. Thanks for watching. If you found this video helpful, give it a thumbs up, subscribe to the Data Guy for more beginner friendly data engineering content, and share this video with someone who is just starting out. Have questions or ideas for future videos? Drop them in the comments below. I would love to hear from you. Until next time, happy coding.